In this video, we'll be going through the IB definition of what an outlier is. But before we do that, let's revisit the 5-number summary. The 5-number summary is the minimum value, which is the smallest number in a data set, Q1, which is the median of the first half of the data, Q2, which is the median of all the data, Q3, which is the median of the second half of the data, and the maximum, which is the largest number in the data set. We will be using all 5 when we calculate an outlier. So, how does the IB define an outlier? Well, it defines it as any value more than 1.5 times the interquartile range above Q3, or any value less than 1.5 times the interquartile range below Q1. So if we drew a diagram, it would look like this. There is my box plot with the interquartile range clearly shown between Q1 and Q3, the maximum at one end and the minimum at the other. I've also marked on 1.5 times the interquartile range above Q3 and 1.5 times the interquartile range below Q1. So an outlier would be any value that falls into this region or into this region. Question 1. The length L centimeters of a sample of 9 otters measured to the nearest centimetre by a wildlife research team are 76, 77, 91, 65, 63, 36, 92, 61, 88. Calculate the 5-number summary for the population of otters. B. Show if the otter with a length 36 centimeters is an outlier. The first thing we need to do is put the list of numbers in order. In order, the list is 36, 61, 63, 65, 76, 77, 88, 91, 92. So the minimum is 36. We'll do the median next. The median is the middle number. Because there is an odd number, there will be a middle number, which is 76. The maximum is 92. So Q1, I want the median of the bottom half, or the median of the bottom half is halfway between 61 and 63, so that will give me 62. And Q3 is halfway between the top half, so that is halfway between 88 and 91, so Q3 is 89.5. For part B, the first thing we need to do is calculate the interquartile range. So the interquartile range is equal to Q3 minus Q1, which is equal to 89.5 minus 62, which is equal to 27.5. We need to work out 1.5 times the interquartile range. Well, that is 1.5 times 27.5, which is equal to 41.25. And now to find out the outliers, so the lower bound is 62 minus 41.25, which is equal to 18.75. Therefore, 36 is greater than 18.75, therefore not an outlier. Question 2. For the data set 16, 14, 3, 12, 15, 17, 22, 15, 52, A. Find the 5-number summary. B. Show that 52 is an outlier. I'm going to find the 5-number summary using a GDC. I've opened the TI Inspire ATE Data and Spreadsheets page. I'm going to input my data into column A. I'm going to call the column X. So now put in my data 16, 14, 13, 12, 15, 17, 22, 15, 52. So that's my data. Go back up to the top. If I want to do that, I can go Control 7. Right, you need to highlight any spare cell. So I've highlighted B1. And I'm going to Menu, 4 Statistics, 1 Statistical Calculations. We've only got one variable, so it's 1. So I've only got one variable, statistics. OK. Right, we called our list X. Everything else can stay the same. So now press OK, and I get a list of numbers. So I've got the mean, I've got the sum of X, the sum of X squared, 2 calculations for standard deviation. And if I keep going down, the number of pieces of data is 9. And then I get my 5-number summary. So the minimum is 12. Q1 is 13.5. The median, or Q2, is 15. Q3 is 19.5. And the maximum is 52. For part B, the first thing we need to do is calculate the interquartile range, which is equal to Q3 minus Q1, which is equal to 19.5 minus 13.5, which is equal to 6. Now we need to calculate 1.5 times the interquartile range, which is 6 times 1.5, which is equal to 9. Right, 52 is above Q3, so Q3 plus 1.5 times the interquartile range is equal to 19.5 plus 9, which is 28.5. Now comparing 52 with 28.5, 52 is greater than 28.5, therefore is an outlier.